this is the model I'm making my circuit. Okay, so I split this into three parts just to be able to demonstrate here how the feedback coil gives the zero phase signal when the cell is in tune. Okay, let me just explain. Let me just explain a little about what's going on. Here I get my chokes, my resonant charging chokes, and this has 39 millihenries and a coupling of 1.87, and so I had to add 5 nanofarads capacitors to each to resonate at 10.4 kilohertz. Okay, so this is my input transformer split into three parts. So this is the primary coil, and this is the secondary coil having 1/3 of this, but this has a dual coil. So here you won't see the correct number, but this is what it is. So here I'm getting 90 volts in, and I'm getting 30 volts here and 30 volts here. So I'm resonating this, and that's one thing. Now we get this is a transformer having a good coupling and 1:5 ratio. Okay, and this is a transformer having a low coupling and 1:5 ratio also. So what I'm going to show here is how the phase is going to behave in the case where we get a short circuit or if we don't get a short circuit. First of all, let me explain this inductor here is kind of the leakage inductance from this secondary coil here. So we model the leakage inductance here in series, and we just add this resistor to show the, the, the voltage output of this coil. Okay, so now we see that with open circuit we get that this voltage is in phase with this voltage, right? You see, these voltages are in phase because they are because this coil is not loaded. Actually, it's loaded by this 100K. If we put, for example, 1 mega ohm, would be kind of less loaded. That's you see, get the perfect square. But when we add a short circuit, look at what happens. It gets reversed phase. Why that? Why that happens? Because this has a low coupling, so its voltage output when we have open circuit here, it's only 87 volts with this 1 mega ohm. Even if we have the turn ratio 1:5, right? Here you get 437 in this resistor, and it's even 1K resistor. We could even get 1 mega ohm, for example, and then you see that you get 489 volts. Okay, peak to peak, I guess. So I guess we get 90 volts here, and when we short it, look what happens. We get 500 volts. You see, we get the voltage that we get on the other secondary, but we get it with opposite phase. You see that, so that's how we use the feedback coil that is going to be wound with high coupling to this secondary coil, but low coupling also to the primary coil. So we are going to use this to detect when we open circuit, when we get to match the water resonance, that we get the phase signal to lock the phase lock loop. So that's it for now. Good night.